Section 8.2, Characteristics of Quadratic Functions. If you need to review what we've learned about parabolas so far, go back and watch the 8.1 video. But if you think you remember, then answer the following questions. Look at the parabola that's graphed to the right. How does that parabola open? And so what do you know about the letter A? What are the coordinates of the vertex? And is it a maximum or a minimum? The equation for the line of symmetry is the domain is, and the range is. Everything that we've determined about this parabola has been done from the graph. We're going to continue in that vein, just looking at graphs of parabolas. Remember when we worked with linear equations and we found the x-intercept? What did that mean? Well, graphically it meant the point where the line crossed the x-axis. Algebraically, though, it meant that if we set y equal to 0, we can find out the point where the line intersected the x-axis. We're going to do the same thing with quadratic functions. Take a look at this graph. It appears that the 0 for the parabola is x is equal to 3. That is the point where it intersects the x-axis. It's one point only, or so it appears. But will x equaling 3 make y equal to 0? Substitute 3 in for x in the above equation and find out. Notice that if a parabola has only one 0, the 0 is the x-coordinate of the vertex. In this parabola, it appears that there is no 0. That means the parabola will not cross the x-axis, and there are no values for x that will make y equal to 0. For this parabola, it appears that there are two zeros. That means the parabola will cross the x-axis twice, and there are two values for x that will make y equal to 0. To be positive that these were the correct zeros, the correct x-intercepts, substitute in x equals -2 and x equals 4. Don't forget that PEMDAS is extremely important and that we need to make sure that you square first. So a -2 squared is 4. Multiplied by the negative in the front, that makes it a -4. Plus another -4 equals a -8, plus the c, which was 8, -8 plus 8 equals 0. So that particular x is perfect. How about with x equaling 4? 4 squared is 16, becomes a -16. A -16 plus a +8 plus a +8 means y is equal to 0. So that 0 that it appeared to be is accurate. But what happens if we don't have a graph and only have the quadratic equation and we want to find the vertex? Well, we could set up a function table and then graph it and then look for the vertex, but there has to be an easier way. And in algebra, we know that there is. So look at that equation, y equals 2x squared plus 12x minus 7. The first thing I want you to do is identify the a, b, and c. The a is 2, the b is 12, and the c is a -7. So to find the vertex algebraically, we use this formula. X is equal to b over 2a, and then take the opposite. So we know that the b is 12. And we know that the a is 2, and we're just going to substitute those into the equation. So 12 over 2 times 2, which is 4. 12 divided by 4 is 3. And then don't forget this negative out here. So x is equal to a negative 3. Great! There's our x-coordinate and the equation for the line of symmetry all from one formula, because x equals a negative 3 is also the line of symmetry. But since the vertex is a point, we need to find the y-coordinate. How? Tell me how, and then find the vertex. Find the vertex of the quadratic equation shown here. Get the x-coordinate, and don't forget to find the y-coordinate. Just to wrap up, find the vertex of the parabola given that equation. What's the equation for the axis of symmetry? Look at this parabola that's graphed here. Find the vertex. What is the equation for the axis of symmetry? And what are the zeros of the parabola? Once you've finished this, please try the practice B that's on Google Classroom.